Alright, so we've just looked at simplifying fractions. What if I ask you to do something like this? 25 over 36 times 24 over 55. How do you multiply fractions? You multiply straight across. Now here's what I do not want you to do. Do not actually multiply 25 times 24 and come up with a number. I don't want that. Okay. What we should be able to do is look to simplify before we multiply. Okay. This is just one big fraction when you multiply. And remember, the great thing about multiplication is that the order doesn't matter. So in your head, you kind of flip these around if you want to, but it doesn't matter. They're all connected. So do you see common factors between the numerator and denominator? There's a common factor of 5 between these two guys, right? So 5 goes in here 5 times, and 5 goes in here 11 times. Okay? Now can 5 reduce with the 36? Can 5 reduce with the 11? No, and remember, we're never canceling side to side here. It's always something in the numerator with something in the denominator. Alright, what about 24? 12 goes into both of these guys, right? You could use 6, you could use 4, but 12 is the greatest common factor. 12 goes in here twice. 12 goes in here 3 times. So what do we have? Right, we're left with 10 over 33. Okay. Any questions about that guy? Right. And did I need to get a common denominator to multiply? No, we don't do that.
No.
We remember that when we were trying to multiply fractions, just multiply the numerators, multiply the denominators. Now, if we are doing division, how do we do that? Right, you keep the first guy the same, and then you multiply times the reciprocal of this guy, so that's D over C. And you just turn it into a multiplication problem and you run with it. You guys with me on that? So what do you think you would do if I gave this problem to you? If I have x squared plus 7x plus 12 divided by x squared minus 9 times this other rational expression, x squared minus 8x plus 15 over x squared minus 12x plus 35. Now before you freak out, you just need to understand that what you're looking at is basically half a quiz. You have 4 polynomials that need to be completely factored, and then you're going to look for common factors that will simplify. So, take it away. What can I do with this first numerator? Here's your hint. It's going to be x plus 3 and x plus 4. What about x squared minus 9? It's going to be x plus 3, x minus 3, that's the difference of squares, times x squared minus 8x plus 15. What happens here? Alright, watch your signs. We have x minus 5, x minus 3. What about that denominator? That's x minus 7 and x minus 5. Do you all agree? Now, what's understood to be between these parentheses right here in the denominator? Multiplication. And what's explicitly written right here? Multiplication. So, to multiply fractions, you just multiply them. Okay? I'm writing the multiplication symbol there so you know that it's all multiplication. It's one huge fraction. And the great thing about multiplication is that the order doesn't matter. So you can't, I don't want you to sit there and go, well, the only guys I can cancel are the x plus 3's because they're one on top of the other. Well, that's true that they do cancel, but that's not the only thing that does reduce. What else can reduce? X minus 3, because you have one factor in the denominator, one in the numerator. What else? X minus 5. So what are we left with? We have x plus 4 over x minus 7. Now remember, in order to cancel correctly here, you have to have everything factored completely. Everything here is written in terms of multiplication, the same as what we have here in the denominator. When you have that, then you can look at canceling common factors, one on the top and one in the denominator.